All right, you guys, in 3.3 we're going to talk about proving that the lines are parallel. So before we said if the lines are parallel, then these special things happen with the angles. Now we're kind of sort of going backwards. Remember that the converse of a theorem is found by switching out the hypothesis and the conclusion. So the converse of a theorem is not automatically going to be true. If it is true, it must be stated as a postulate or proved as a separate theorem. So the following ones are going to be true for us, and these are the ones that we're going to use. There's going to be 4 of them. So I'm going to start with one, and I'm going to show you how to work it through. I'm going to give you another one, and hopefully you know how to work it through, and then we'll kind of sort of come together on this. So this first one that we're going to talk about is the converse of the corresponding angles. Remember, corresponding angles are congruent, right? So originally we said if we had these lines in a transversal, so if the lines are parallel in a transversal, then our corresponding angles, the ones that make the F, so the ones that make the F are going to be congruent, right? Well, remember that the converse means that we switch the hypothesis and the conclusion. So in this case, it says if 2 lines are cut by a transversal and you see that these angles are congruent, they happen to make this F, you see that the angles are congruent. If those angles are congruent, then you have just proved that those 2 lines are going to be parallel. Using this information, so use the converse of the corresponding angles postulate, they want you to prove that the line L and M are going to be parallel to each other. Well, they give you some information. They tell you that the measure of angle 3 is going to be 4x minus 80. And they tell you that the measure of angle 7 is going to be 3x minus 50. Then they also tell you that x is going to be 30. They want you to use the converse of that postulate to help you show that those lines are parallel. Remember, if I can prove that these lines are congruent, that the angles are congruent, if those corresponding angles are congruent, then by this converse postulate, those lines have to be parallel. So let's write this out so that you guys can see. So if angle 3 is going to be congruent to angle 7, then we know, sorry you guys, that line L is parallel to M. Okay? So first we have to check, if their measures, so the measure of angle 3 is equal to the measure of angle 7. So let's see this. So step number 1, to see if they're equal, let's plug this in. So step number 1, I'm going to go ahead and take 4 times 30 minus 80, and I'm going to plug this in, and then I'm going to take 3 times 30 minus 80. This, remember you guys, is the substitution property. Okay, and what happens is you get that this was the measure of angle 3, this is the measure of angle 7. So what happens is you get that this one equals 40, that's 120 minus 80, and this one equals 40. So what happens is you realize that the measure of angle 3 has to equal the measure of angle 7. And if you remember correctly, if angle 3 is 40 and angle 7 is 40, well, cut out the middle man, and we get angle 3 is congruent to angle 7. This, remember, is the transitive property. Okay? If the measures are equal, you should know that your angles have to be congruent to each other. So angle 3 has to be congruent to angle 7. This, if you remember, is actually the definition of congruent angles. Okay? And if the angles are congruent, then your lines have to be parallel. That's what this converse is all about. So in your last step here, we can say L is actually parallel to M, and the reason for that is the converse of the corresponding angles theorem, or postulate, sorry. All right, so let's just think this over. What the heck did we just do? They wanted you to prove that line L is parallel to M. And they give you two angles that happen to look like corresponding angles. If these two angles are congruent, then these lines are going to be parallel. So, we went through and we checked to see if their measures were the same, which they were. We plugged in 30, so we used the substitution property. Once we figured out that they both equaled the same thing, we cut out the middle man and we said that they equaled each other using the transitive property. Well, if the measures are equal, the angles have to be congruent. That's the definition of congruent angles. And if the angles are congruent here, if those corresponding angles are congruent, then the lines have to be parallel because of the converse corresponding angle postulate. It says if those angles are congruent, that the lines are going to be parallel. This is what we're looking for when we're doing our problems and our homework, you guys. You need to kind of set it up as a 2-column proof. Okay, so like I said before, there were 4, so here's the other 3. We have, of course, the converse of the alternate interior angle theorem, the alternate exterior angle theorem, and the same side interior angle theorem. The converse of the alternate interior angle theorem says if you've got two lines cut by a transversal and the alternate interior angles are going to be congruent to each other, that makes these lines parallel. Likewise, if I've got two lines cut by a transversal and my alternate exterior angles are congruent to each other, then the lines are parallel. And the last one, again, if I've got two lines simply cut by a transversal and same side C are supplementary, meaning that they add to equal 180, then your lines are going to be parallel to each other. You need to know all 4 of these. These are going to help us prove that these lines are parallel. All right, so using what we just learned, I would like for you to actually use all of the information that you've got, all of the theorems, the converse postulates, to show that R is actually going to be parallel to S, knowing that angle 4 is congruent to angle 8. So I'd like for you to go ahead and try this out, and then come back, we'll see if we end up with the same answer. All right, you guys, you should have noticed that if angle 4 is congruent to angle 8, these happen to be alternate exterior angles. Well, if alternate exterior angles are congruent, that would make these two lines, R and S, parallel because of the converse of the alternate exterior angles theorem. Okay, remember, the converse of the alternate exterior angles theorem says that if alternate exterior angles are congruent, these two lines have to be parallel to each other.
So in this example, what we're going to do is we're going to use the given information and the theorems that you have just learned to show that lines R and S are indeed parallel. So they give us that angle 2 is 10x plus 8, and that angle 3 is 25x minus 3. So if we look at these, we do notice, hopefully, that these two angles are a specific type of angles, and they're same side C's. Now, I do realize from the previous couple slides that you know that the following: if same side C's are, hopefully you say supplementary, then lines are parallel. So really all we have to do is just prove that these two angles are supplementary. Now, for them to be supplementary, what it means is we're going to have to add them and set them equal to 180. So we've got them written down. 10x plus 8 plus 25x minus 3 equals 180. Now, the best thing about this problem is they even give us what x equals. So if we take that x and we shove it in, what we're going to be doing is we're going to be proving, or at least trying to prove, that this is a true statement. So I shoved the 5 in for every x. So I've got 10 times 5, so I get 50 plus 8. That'll be 58 plus 25 times 5. Well, 25 times 5 is 125 minus 3 ends up giving me, here we go, I got this, 122. And when you add 58 and 122, you end up getting 180. So we did indeed get a true statement. Therefore, this proves to us that R and S are parallel. So taking a look at this example, this is probably one of the hardest examples that we're going to run through in this set of notes. What we want to do is we want to work with the given pair of congruent angles, or supplementary in the last couple examples, and we're going to state if any of the lines are indeed parallel, and if they are, we're going to tell you which lines are parallel. Just a little bit of a refresher, remember that if you're working with alternate interiors, which make the letter Z, alternate exterior, which make the letter V, or corresponding angles, those have to be congruent in order for lines to be parallel. And if we're working with same side Cs are supposed to be supplementary in order for lines to be parallel. So for our first part A, we're dealing with angles 10 and 12. And angles 10 and 12 are on my diagram right here. And we do notice that they form the letter Z. So if they form the letter Z, I'm supposed to have congruent, and it is true, they are indeed congruent, which means that I could possibly have parallel lines here. So angle 10 is made up of line A and Y, and angle 12 is made up of line B and Y. They both share Y, so Y is my transversal, meaning that A and B are parallel. So let's go ahead and take a look at part B. So if I'm working with angle 3 and 10 in this case, so I've got angle 3 and I've got angle 10, I notice that these angles make the letter C. And since they make the letter C, they should be supplementary. My problem here is it doesn't say supplementary, it says congruent. Since it says congruent, I cannot assume that the lines are parallel because it doesn't follow our chart of information. And we said that with same side C's, they have to be supplementary. So in this case, we do not have parallel lines because it doesn't say supplementary. So the next pair of angles would be 2 and 10. And if we're looking at 2 and 10, I've got angle 2 here, and I've got angle 10 down here. But if we connect them together, they make the letter F, and F's are supposed to be congruent, so corresponding angles are supposed to be congruent, and that's what's stated here. So by looking at angle 2 is made up of line X and A. Angle 10 is made up of line Y and A, and since they share the A, that's the transversal, so X and Y are parallel. Why don't you do this? Why don't you try out the next couple of them on your own, and then what I'll do is I'll come back and we'll walk you through together. Alright, so we're taking a look at D now, and it says angles 5 and 15. So if I look at angle 5 and angle 15, now you first might say, oh, those make the V's. The problem with this is they don't share a transversal. 5 is made up of lines X and B, and 15 is made up of lines Y and C. So they don't share a transversal, and when you don't share a transversal, you can't have a specific set of angles. Therefore, that is why we have none for our answer for D. E. For E, we were dealing with 8 and 15. So if we take a look at angle 8 and angle 15, those make the letter Z. Z's are alternate interior angles and must be congruent. Check that off. We do have congruent. So the two lines that are parallel are X and Y because 15 is made up of Y and C. 8 is made up of X and C. They both share the C. That's my transversal. Therefore, the other two lines are parallel. If we take a look at 1 and 4, 1 and 4 are corresponding. So angle 1 and angle 4, they make the letter F. If they make a letter F, they must be congruent, and that's what we have listed. Therefore, angles 1 and 4 are congruent, corresponding. We end up getting angle 1 is made up of A and X, 4 is made up of B and X. They share X as my transversal, therefore A and B are parallel. G, angle 3 and angle 6. If we're taking a look at angle 3 and angle 6, those two angles might seem a little far apart. but these actually make the letter Z, and we do have congruent, which is good. And the two lines that should be parallel are A and C because the transversal was X that was shared. In H, I've got 2 and 9. They're supplementary. So if they're supplementary, they should make a C. But according to what we have here, I've got 2 and I've got 9. Those are actually alternate extra angles. They make the letter V, and they should have been congruent. But it says they're supplementary. That is why it is none, because it doesn't match the charts that we're working with. 2 and 6, if you're working with 2 and 6, instead of the 9, we'll work with the 6 here. Those are actually same-side C's, and same-side C's are indeed supplementary, so then A and C are the parallel ones because X was my transversal. And then for the last one, 5 and 14 are supplementary. If I look at 5 and 14, 5 and 14 do indeed make the letter C. They are same-side C's, and they are stated as supplementary. Therefore, X and Y are my parallel lines because my transversal was B. Hopefully this makes sense. If you got any questions on it, please make sure you ask in class. Otherwise, have a great night.